Hi everyone, this is Poojitha from Sri Venkateshwara College of Engineering, Department of CSE AI. Today let us see our topic called First Order Logic in the subject AI, that is nothing but Artificial Intelligence. Now let us see Introduction to First Order Logic. Introduction. First Order Logic is a formal system used in mathematics, philosophy, linguistics and the computer science. It allows for reasoning about entire entities and relationships between them using quantifiers and predictors. FOL is more expensive than propositional logic as it can handle variables, functions and quantifiers. Now let us see first order logic. World consists of objects, relations, functions. Sentences are made up of symbols for constant objects, predicates and the functions. Concatives as PL, quantifiers and variables. That's nothing but for all x and for all y. Now let us see syntax of our first order logic. Syntax. A word consists of terms such as constants, variables and the functions and formulas such as atomic formulas and the compound formulas. Atomic formulas are built from predicates applied to terms. Compound formulas are found by connecting atomic formulas using logical connectives like and, or, and, not. Syntax of FOL. John, Sally too. See, that is nothing but constants. Now, variables are nothing but X, Y, A, B. Predictates are nothing but person, that is nothing but name of the person, that is nothing but John. Siblings, John and Sally, and is odd of size 2. Functions, mother of John, comma square root of X. Connectives are nothing but symbols. Equality is nothing but equals to. Quantifiers are nothing but for all. Terms are nothing but constant or a variable or a function, and atomic sentences are nothing but predicted, nothing but term 1 to term n. Complex sentences, complex sentence that are nothing but made from atomic sentences using connectives and the quantifiers. Now let us see what are quantifiers in first order logic. FOL includes existential, that is nothing, and universal quantifiers. The existential quantifier asserts that there exists at least one element that satisfies a given property. The universal quantifier asserts that a property holds for all elements in a domain. First order logic syntax, nothing but user defines these primitives. Constant symbols, that is nothing but the individuals in the world. Example, marry, come, marry and three. Function symbols, mapping individuals to individuals. Example, father of Mary equals to John, color of sky equals blue. Predicted symbols are mapping from individuals to truth values. Example, greater of 5, 3, green of grass, color of grass or green. Now let us see what are semantics of first order logic. In FOL interpretation, assign meaning to symbols and determine the truth of formulas. An interpretation consists of a domain of objects and mapping of functions and the predictates. A formula is true under an interpretation if it is holds for all the elements in the domain. Now let us see inference rules in first order logic. In FOL, inference rules like modus ponens and universal instantiation are used to drive new conclusions from existing premises. Soundness ensures that if the premises are true, the conclusion derived using inference rules will also be true. Completeness ensures that if a conclusion is true, that can be derived using the inference rules. Now let us see what is resolution in first order logic. Resolution is a fundamental inference technique in FQL for automated reasoning. It involves converting formulas into clausal form and resolving conflicting clauses to drive new clauses. Resolution is used in automated theorems providing logic programming and AI applications. Now let us see what are the applications of first order logic. Applications. FOL is widely used in artificial intelligence for knowledge, representation and reasoning. It forms the basic for logic programming languages like Prolong. FOL is also employed in natural language processing for semantic analysis and an understanding. First order logic. Propositional logic is limited, cannot represent information concisely, We want something more expressive. First order logic allows the representation of objects, functions and objects, and relation between objects. Allows us to represent almost any English sentences. Now let us see what are the limitations of first order logic. Limitations. FOL has limitations in representing uncertainty and default reasoning. It struggles with handling non-monotonic reasoning where new information may invalid prevision conclusion. FOL may not be suitable for modeling complex cognitive processes that involve emotions or subjective judgments. First order logic FOL, that is the word syntax. Sentences are built up of terms and atoms. Now let us see what are extensions of first order logic. Many extensions and validations of FOL have been developed to address its limitations. Modal logic adds operators for expressing necessity and possibility. Description logic extends FOL with constants for defining concepts and relationships. Now let us see conclusion of a topic called first order logic. First order logic is a powerful formalism for representing and reasoning about complex systems. Its syntax, semantics and inference rules provide a solid foundation for various applications in mathematics, philosophy and computer science. Understanding FOL is essential for anyone interested in logic, artificial intelligence or formal methods. First order logic models the world in terms of objects which are things with individual identities, properties of objects that distinguish them from other objects, relations that hold among sets of objects, functions which are subset of relation where there is only one value for any given input. Examples: objects, remote, students, lectures, companies, cars, etc. Relations: brother of, bigger than, outside, part of, as color. Occurrence after, owns, visits, predicts. Properties: blue, oval, even, large. Functions: father of, best friend, second of, one more than.